There was a magical pond between three temples. If anybody would wash the flowers in the pond, the flowers doubled. So once a person went to a garden, plucked some flowers and washed it in the magical pond and kept some flowers in one temple. After that, he went to the pond and washed the remaining number of flowers and kept the exact number of flowers that he kept in the first temple in the second temple. He again washed the remaining number of flowers and again kept the same number of flowers he kept in the first and second temple in the third temple, and he was at last left with 0 flowers. So what are the number of flowers he plucked from the garden and what are the number of flowers he kept in every temple? This is a popular interview puzzle asked in several job interviews. Feel free to pause the video and give a try before checking the solution. Let me explain the solution now. According to the puzzle, there are 3 temples and 1 magical pond. If anybody would wash the flowers in that pond, the flowers doubled. In all the temples, there are exact number of flowers kept. We are supposed to find total number of flowers plucked from the garden and what are the number of flowers kept in every temple. Suppose a person start the trip with X flowers and he leave Y flowers at each temple. Here are the number of flowers person have it after each stage of the trip. So at the start, let the number of flowers he plucked be X. Now in pond, he washed X number of flowers. This will result in 2X because if anybody would wash the flowers in that pond, the flowers doubled. Now let the number of flowers he kept in each temple be Y. Hence, at temple 1, Y number of flowers are kept. After this, number of flowers left will be 2X minus Y. Now again in pond, he washed 2X minus Y number of flowers. This will result in 2 times 2X minus Y, which is equal to 4X minus 2Y. This is because we already know if anybody would wash the flowers in that pond, the flowers doubled. So now at temple 2, Y number of flowers are kept again. After this, number of flowers left will be 4X minus 2Y minus Y, which is equal to 4X minus 3Y. Again in pond, he washed 4X minus 3Y number of flowers. This will result in 2 times of 4X minus 3Y, which is equal to 8X minus 6Y. Because we already know that if anybody would wash the flowers in that pond, the flowers doubled. Finally, at temple 3, Y number of flowers are kept. After this, number of flowers left will be 8X minus 6Y minus Y, which is equal to 8X minus 7Y. As per the puzzle, after placing flowers at the third temple, person have no flowers. This means the final equation is equal to 0. Here the final equation is 8x minus 7y, hence 8x minus 7y equals 0. After simplifying, x equals 7 over 8 times y. We want to find whole number solution to this equation. As the fraction 7 over 8 cannot be reduced any further, the variable y needs to be a multiple of 8 to eliminate the denominator. The smallest value for y is 8, which means the smallest value for x is 7. So the answer is person started with 7 flowers and he left 8 flowers at each temple. So let's validate the solution now. At start, let the number of flowers he plucked is 7. In pond, he washed 7 flowers. This will result in 14 because if anybody would wash the flowers in the pond, the flowers doubled. Now the number of flowers he kept in each temple is 8. Hence at temple 1, 8 flowers are kept. After this, number of flowers left will be 14 minus 8, which is equal to 6. Now again in pond, he washed 6 flowers. That will result in 12 because we already know if anybody would wash the flowers in that pond, the flowers doubled. Also, we know that the number of flowers he kept in each temple is 8. Hence, a temple to 8 flowers are kept. After this, number of flowers left will be 12 minus 8, which is equal to 4. Now again in pond, he washed 4 flowers. This will result in 8 because the number of flowers doubled. Finally, in temple 3, 8 flowers are kept because that is the number of flowers he kept in each temple. After this, number of flowers left will be 8 minus 8, which is equal to 0. And this is what it is expected. The solution to this puzzle is the person plucked 7 flowers from the garden and 8 he kept in every temple. So by following these simple steps, we can find the solution in less time and accurately. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer logically. Let me explain the solution now. As per the puzzle, there are series of numbers which are given and it contains integers from 1 to 50 and which includes both 1 and 50. However, the numbers are in a jumbled form and there is one integer missing. Our task is to identify the missing integer logically. Okay, we know that the sum of all the numbers from 1 to n can be calculated by using the formula n times n plus 1 over 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. Let's understand this equation with simple example. Let's consider a series with 5 numbers 1, 2, 3, 4, 5. We can use the equation to find the sum of these numbers. Here the last number in the series is 5, hence n is 5. Hence this will result in 5 times 5 plus 1 over 2, which is equal to 15. Similarly, we will try for 50 numbers and hence n becomes 50. Therefore, sum of all the numbers from 1 to 50 is 50 times 50 plus 1 over 2. Here n is 50. And after simplifying, and we get 50 times 51 over 2. And further simplification, we get the value 1275. Hence, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integer present in the given series and subtract the sum from 1 to 75. The difference between 1 to 75 and this sum would give us the missing integer. Because 1275 is the sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. By following these simple steps, we can find the solution for this particular puzzle in less than a minute. How can 4 employees calculate the average of their salaries without knowing others' salary? Here 4 employees want to know the average of their salaries. They are not allowed to share their correct individual salaries. How this can be achieved and what is the right way to solve this problem? First of all, this solution has a limitation that information is partially passed and there needs kind of some trust level. So let's say the 4 co-workers are A, B, C and D and their individual salaries are SA, SB, SC and SD respectively. For knowing the average of their salaries without disclosing their own salaries to each other, they have to follow these steps. In the first step, A adds a random amount, say RA, to his own salary and gives that to B. B won't be able to know A's salary as he has added a random amount known to him only. In this case, B will receive the figure SA plus RA from A. In the next step, B adds a random amount, say RB, to his own salary and gives that to C without showing that to A. C won't be able to know B's or A's salary as it was added a random amount known to individuals only. Now C will get the figure SA plus RA plus SB plus RB. In the next step, C does the same and gives the final figure to D without knowing it to B. Now D will receive the figure SA plus RA plus SB plus RB plus SC plus RC. In the next step, D does the same and gives the final figure to A without showing it to C. Now A will receive the figure ACA plus RA plus SB plus RB plus SC plus RC plus SD plus RD. Now A subtracts his random amount since A knows the random amount initially added and gives the final figure to B without showing that to D. B will now receive the figure SA plus SB plus RB plus SC plus RC plus SD plus RD. Here the random amount which was initially added by A is not present. In the next step, B subtracts his random amount and gives the final figure to C without showing it to A. C will receive the figure SA plus SB plus SC plus RC plus SD plus RD. In the next step, C does the same thing, that is C subtracts its random amount and gives the final figure to D without showing it to B. C will receive the figure SA plus SB plus SC plus SD plus RD. And finally, D subtracts his random amount and then the figure becomes SA plus SB plus SC plus SD. Now D knows that sum of all salaries. Now it is easy to get the average by dividing the final figure by 4, which was asked as a part of the puzzle. By following these simple steps, we can find the average of 4 employees' salary without knowing others' salary. We can apply the same technique to know the average of more than 4 people as well. We just need to remember that at every stage, only 2 people should share the figures and rest others should not be communicated. John and Peter are selling chocolates. John was selling at the rate of 2 pieces per rupee and Peter was selling at the rate of 3 pieces per rupee. Now both of them decided that they will mix their chocolates and sell them at the rate of 5 pieces for 2 rupees. After selling whole chocolates, they found that the total collection is rupees 7 less than what they would get by selling them separately. Note, initially both have equal number of chocolates. Find how many chocolates each of them had initially. This selling chocolates puzzle is an frequently asked interview question. Let me explain the solution step by step. Let us assume that John and Peter had X number of chocolates, each of them initially. Money earned by John when he sells chocolates separately is total chocolates with John over number of pieces per rupee. Hence, money earned by John is X over 2 as he sells 2 chocolates per rupee. Money earned by Peter when he sells chocolates separately is total chocolates with Peter over number of pieces per rupee. Money earned by Peter is X over 3 as he sells 3 chocolates per rupee. Total money earned by both of them by selling chocolates separately would be X over 2 plus X over 3. Now let us find out the equation for money earned if they sell chocolates together at 5 pieces per 2 rupees. We know each have X number of chocolates, so the total number of chocolates that both have is 2 times X. They sell 5 chocolates per 2 rupees, and hence every 5 chocolates is considered as one piece sold for 2 rupees, which is 5 over 2. Hence total money earned in combined manner is total chocolates with John and Peter over 5 pieces per 2 rupees. It is given as 2 times X over 5 over 2. Now the equation becomes X over 2 plus X over 3 equals 2 times X over 5 over 2 plus 7, as there is 7 rupees short when they sell chocolates in combined way. Solving the above equation for X gives the number of chocolates each of them had initially, which is 210 chocolates. Hence answer to this puzzle is 210 chocolates. By following these steps systematically, we can solve this kind of puzzles in interview in a given time. A horse and a camel were carrying boxes on their backs. The horse started complaining to the camel that his load is too heavy. The camel replied, "Why are you complaining? If you gave me one of your boxes, I would have double what you have. And if I give you one of my boxes, we too would have an even load. How many boxes do each of the animal, that is horse and camel, is carrying?" Let me explain the solution now. Let's assume C be the number of boxes that camel is carrying and H be that being carried by horse. As per first part of camel's statement, that is, if you gave me one of your boxes, I would have double what you have. This can be expressed in the form of equation like this. C plus 1 equals 2 times H minus 1. C plus 1 because as per the statement, if you give me one of your boxes, which means we need to add 1 to number of boxes that camel is carrying. And 2 times of H minus 1 is because in the same statement it says adding 1 more boxes to C will result in double what horse have. We have to subtract 1 because this equation is valid if 1 box is given to camel. Now solve this equation. After simplification, equation becomes C plus 1 equals 2H minus 2 and C equals 2H minus 3, and call this as an equation 1. Now in second part of camel's statement suggests, if I give you one of my boxes, we too would have an even load. This can be represented as C minus 1 equals H plus 1 and C equals H plus 2. We know as per the first equation, C equals 2H minus 3. Now substitute the value of C here. Equation becomes 2H minus 3 equals H plus 2. After solving, H equals 5. Again putting the value of H in the equation 1, which gives C equals 2 times 5 minus 3, which is equal to 10 minus 3, and which is equal to 7. That is C equals 7. Thus answer to this puzzle is horse is carrying 5 boxes and the camel is carrying 7 boxes. An intelligent trader travels from one place to another carrying 3 sacks having 30 coconuts each. No sack can hold more than 30 coconuts. On the way, he passes through 30 checkpoints, and on each checkpoint he has to give 1 coconut for each sack carrying. How many coconuts are left in the end? Let me repeat the puzzle. An intelligent trader travels from one place to another carrying 3 sacks having 30 coconuts each. No sack can hold more than 30 coconuts. On the way, he passes through 30 checkpoints, and on each checkpoint he has to give 1 coconut for each sack carrying. The question is, how many coconuts are left in the end? Let's assume that the maximum capacity of each sack is 30 coconuts. In the first view, most of the people thinks that the answer to this puzzle is 0. If you take all conditions literally, then nothing would be left. But the keyword here is intelligent trader. So you need to think according to an intelligent trader. Being an intelligent trader, he will definitely use all his intelligence to get the profit, that is by trying to save as much coconut as possible. Now I am going to explain step by step how the trader is going to save maximum coconuts possible. Initially, the trader passes through 10 checkpoints, leaving the trader with 20 coconuts per sack. It is because on every checkpoint, the trader has to give one coconut from each sack. This means at the end of 10 checkpoints, total left out coconuts in each sack is 20. The trick to save coconuts lies at this point. At this point, what trader does is, he distributes all coconuts from one sack into the other two sacks, leaving two sacks each filled with 30 coconuts, and one sack will be empty at this point. From here, at each checkpoint, trader have to give only 2 coconuts because there are only 2 sacks left. Later, trader passes through 15 more checkpoints. After passing through 15 more checkpoints, the trader now has 15 coconuts per sack, or 30 coconuts in total. At this point, trader will transfer the coconuts into one sack. Now the trader is left with 30 coconuts in a sack. From here, at each checkpoint, trader have to give only one coconut because there is only one sack left. By this point, 25 checkpoints already covered and remaining checkpoints are 5. Now trader will pass through the 5 remaining checkpoints, and if trader spends another 5 coconuts in other 5 checkpoints, the trader is left with 25 coconuts. Thus answer to this puzzle is the total number of coconuts left in the end is 25. Two trains are on same track and they are coming toward each other. The speed of first train is 50 km per hour and speed of second train is 70 km per hour. A bee starts flying between the trains when the distance between two trains is 100 km. The bee first flies from first train to second train. Once it reaches the second train, it immediately flies back to the first train, and so on until trains collide. We are supposed to calculate the total distance traveled by the bee, given that speed of bee is 80 km per hour. Let me explain the solution now. Let us make some assumptions first. Let the first train A move at u kilometers per hour. Let the second train B moves at v kilometers per hour. Let the distance between two trains be d kilometers, and let the speed of B be b kilometers per hour. In order to solve this particular puzzle, it is important to understand what is speed. Speed tells us how fast something or someone is traveling. You can find the average speed of an object if you know the distance traveled and the time it took. The formula for speed is speed equals distance divided by time. To work out what the units are for speed, you need to know the units for distance and time. In this puzzle, distance is in kilometers and time is in hours. So the units will be in kilometers per hour. The formula speed equals distance divided by time can be rearranged just like any other equation. The formula can be rearranged in 3 ways. In order to calculate speed, the formula becomes speed equals distance divided by time. To find distance, distance equals speed multiplied with time. To calculate time, time equals distance divided by speed. To calculate one of the variables, speed, distance or time, we need the other two. Therefore, the time taken by trains to collide in this puzzle equals distance divided by speed. Here distance is d and speed is sum of speed of train A and train B, which is u plus v. Hence time taken by trains to collide equals d divided by u plus v. Now putting all the known values into the above equation, we get, so we know that u equals 50 kilometers per hour, v equals 70 kilometers per hour, d equals 100 kilometers, and b equals 80 kilometers per hour. Therefore, the total distance traveled by b, that is distance, equals speed multiplied with time. We know that speed of b is 80 kilometers per hour and total time b travels is d divided by u plus v. After substituting, the equation becomes distance equals b multiplied with d divided by u plus v. Substituting the values of b, d, u and v, equation becomes 80 times 100 divided by 50 plus 70. After solving, it results in approximately 66.67 kilometers. Thus, total distance traveled by B is 66.67 kilometers. I am sharing one more similar puzzle. Try to solve this by yourself before checking the solution. Puzzle states that there are two trains, say train A and train B, running on the same track towards each other at a speed of 100 kilometers per hour. They enter a tunnel 200 kilometers long at the same time. As soon as they enter, a supersonic bee flying at a rate of 1000 kilometers per hour also enters the tunnel from one side, say train A side. The bee flies towards the other train B, and as soon as it reaches the train B, it turns back and flies back to the train A. This way, it keeps flying to and fro between the trains A and B. The trains collide after a certain point of time, leading to a massive explosion. The task is to find the total distance traveled by the bee until the collision occurred. Let me explain the solution now. This puzzle can be solved with the help of basic physics and observation. We know that speed of train A and train B equals 100 km per hour. Length of the tunnel equals 200 kilometers. Since both the trains are traveling at the same speed, hence they must have traveled equal distance before colliding, which means that they must have collided at the halfway of the tunnel. Therefore, distance traveled by each train before colliding equals 100 kilometers, because the length of the tunnel is 200 kilometers. And time taken by each train to travel 100 kilometers and collide equals distance divided by speed, which is equal to 100 by 100, which is equal to 1 hour. Therefore, the bee must have traveled for 1 hour before colliding with the trains. Hence, distance traveled by the bee in 1 hour before colliding equals speed multiplied with time, which is equal to 1000 multiplied with 1, which is equal to 1000 kilometers. Thus, total distance traveled by bee until the collision occurred is 1000 kilometers. One person has some money in his pocket. He visits 4 temples on the way. As soon as he visits any temple, the money in his pocket gets doubled, and on his way out, he donates rupees 100 to each temple. In total, he visits 4 temples. After visiting the last temple, his pocket is empty of all the money. So, how much money he had initially? So let me simplify the puzzle. One person has some money in his pocket. He visits 4 temples on the way. As soon as he enters a temple, his money gets doubled and he offers rupees 100 in each temple. Thus his pocket gets empty after he returns from the 4th temple. Now the question is how much money he had initially. Let's assume a person began his quest with rupees X. So what exactly happens in first temple is, as soon as he enters the temple, his money is doubled to 2x. On his way out, he donates rupees 100. Therefore, he is left with rupees 2x minus 100. So 2x because the money got doubled and the 100 because he donates to the temple. So in second temple, as soon as he enters the temple, his money is doubled to 2 into 2x minus 100. 2x minus 100 is the money left before visiting the second temple. So on his way out, he donates another rupees 100 and he is left out with rupees 4x minus 300. This we will get after solving the equation 2 into 2x minus 100 minus 100. In third temple, as soon as he enters the temple, his money is doubled to 2 into 4x minus 300. 4x minus 300 is the money left before visiting the third temple. On his way out, he donates another rupees 100 and he is left with rupees 8x minus 700. So in fourth temple, as soon as he enters the temple, his money is again doubled to 2 into 8x minus 700. We already know that 8x minus 700 is the money left before visiting the fourth temple. On his way out, he donates another rupees 100 and he is left with rupees 16x minus 1500. According to the question, after his last visit, he completely runs out of money. Therefore, the equation is 16x minus 1500, which is the money left after the visit of fourth temple, equals to 0, because according to the question, after his last visit, he completely runs out of money. After solving this equation becomes x equals 1500 divided by 16, hence x is equal to 93.75. Hence a person had started his quest with rupees 93.75 in his pocket. This post contains numbers 7, 0, 2, 3, 5 and it simply asks, how can you make 36 using these numbers, that is 70235. To be more clear, I will provide additional information to avoid confusions. Number 1, we are not supposed to use any numbers apart from 70235. Number 2, repetition of numbers are not allowed. You are allowed to use numbers only once. Number 3, you can use any mathematical operations between numbers but try to solve using only basic mathematical operations such as addition, subtraction, multiplication and division. Just keep these 3 important points in mind while solving this problem. Feel free to pause the video and give a try before checking the solution. Once done, continue watching the video for the right answer. Let me explain the solution now. Remember, this is not the only solution to this question. There might be multiple ways to solve this. Do share yours in the comment section. We already know that we need to use only these 5 numbers, which are 7023 and 5. First and foremost, there should not be any confusion in using the technique to solve this problem. This problem can be solved using the order of operations, which is popularly called by the acronyms PEMDAS or BODMAS. According to the rule, in an expression, first evaluate parentheses, then evaluate exponents, then evaluate multiplication, division, and finally evaluate addition, subtraction. Another important point is, as we know that The result is 36. We just need to try different combinations of the arithmetic operations on these numbers. Also, 36 is a bigger number. We need to multiply two bigger numbers first to get close to the number 36. Hence, first multiply 7 and 5 and rearrange remaining numbers to achieve the solution. So give a try like this. 7 times 5 plus 3 plus 0 and finally minus 2. So after simplification of this expression, you will get 35 plus 3 minus 2. The answer would be 36. So this is one way to solve this problem. By using different technique, we can achieve the same answer in multiple ways. Do share yours in the comment section. The diagram shows two squares. The smaller square has area 18 square centimeters. The larger square has area 50 square centimeters. What is the distance between the two marked vertices? Let me repeat the problem. The diagram shows two squares. The smaller square has area 18 square centimeters. The larger one has area 50 square centimeters. What is the distance between the two marked vertices? Let me explain the solution now. Let P, Q and K be the points shown. We know that the smaller square has area 18 square centimeters. Let's length of each side of a smaller square be A. Hence its area is A square, which is equal to 18 square centimeters. After solving for A equals square root of 9 times 2, which is equal to 3 times square root of 2. Thus, length of each side of a smaller square is 3 times square root of 2 centimeters. Similarly, let's length of each side of a larger square be B. Hence, its area is B square equals 50 square centimeters. After solving, B equals square root of 25 times 2, which is equal to 5 times square root of 2. Thus, length of each side of a larger square is 5 times square root of 2 centimeters. Now, if you observe the figure carefully, QK is equal to B minus A. That is length of side of a larger square minus length of side of a smaller square. Thus, it follows that QK equals 5 times square root of 2 minus 3 times square root of 2 centimeters, which is equal to 2 times square root of 2 centimeters. Applying the same logic to the side KP, the value of KP equals 2 times square root of 2 centimeters. We know from the figure QKP is a right angle triangle. We can apply Pythagoras theorem here. The theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So by Pythagoras theorem applied to the triangle QKP, we have QP square equals QK square plus KP square. Hence the length of QP in centimeters is square root of 2 times of square root whole square plus 2 times square root of 2 whole square. After solving this, the expression becomes square root of 8 plus 8, which is equal to square root of 16. After solving this, we get the value 4. Thus, the distance between the two marked vertices in this figure is 4 centimeters. A father has 17 horses. He gives half of them to his first son, 2/3 of what is left to the second, and 2/3 of what is left of that to his third son. How? Can you tell how many horses each son gets? Let me explain the solution now. The immediate thought comes to mind after reading puzzle is that this question is unanswerable, as of course you cannot divide 17 horses evenly by 2. Additionally, it becomes clear that after the horses are distributed, there will be some amount of horse left over, as the third brother only receives 2/3 of the horses left. So we must think carefully about the right way to solve this puzzle. One approach to solve the problem is like this. In this approach, what is important is the ratio of number of horses from one brother to the other with no horses left over. According to the puzzle, the first brother receives half of all the horses. The second brother receives 2/3 of the remaining half, which is 1/3 of all the horses. The last brother receives 2/3 of the remaining 1/6, which is 1/9 of all the horses, and which leaves 1/18 of all the horses undistributed. Working under the assumption that all of the horses were meant to be given to the brothers, we can ignore that 1/18 and just compare the relative amounts that the brothers receive. This approach may be confusing. The best approach to solve this riddle is just consider a imaginary horse and you merge imaginary horse into that 17 to make it 18, an even number. Now distribute these 18 horses according to the question. So the first son gets half of the total horses, thus he gets half multiplied with 18, which is equal to 9 horses. Total horses remaining is 18 minus 9 equals 9. Now 2/3 of the horses left are obtained by the second son, that is 2/3 multiplied with 9, which is equal to 6 horses. So total horses remaining now is 18 minus 9 minus 6, which is equal to 3. Now the third son gets 2/3 of the remaining horses. So he gets 2/3 multiplied with 3, which is equal to 2 horses. Finally, total horses remaining is 18 minus 9 minus 6 minus 2, which is equal to 1 horse. Remaining horse is your imaginary horse. You can just ignore. So the first son gets 9 horses, the second one gets 6 horses, and the third son gets 2 horses, all because of adding your own imaginary horse. So by following this trick, this puzzle can be solved easily with all conditions satisfied. The problem statement is how many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits. So you are given 4 options. They are 0, 1, 9 and 10. So let me elaborate the problem. So first of all, it is important to understand what are prime numbers. So prime numbers is a number that is divisible only by itself and 1. For example, 2, 3, 5, 7, 11, they are all prime numbers because it is divisible by 1 and itself. So the digits 1 to 5 can be rearranged into many distinct 5-digit numbers. So your task is to find all the prime numbers formed using the digits 1 to 5. So feel free to pause the video and try yourself before checking the solution. Let's everyone know your answer in the comment section. Basically, you need a trick to solve this complex problem. So it is not easy to find the solution to this problem unless you know the trick to find those numbers which are prime numbers. The trick which we can use here is divisibility rules. The most important rule which comes handy here is divisibility rule to find the number is divisible by 3 or not. The rule states that a number is divisible by 3 only if the sum of all digits of a number is divisible by 3. For example, 123 is divisible by 3 because sum of all the digits in the number is 1 plus 2 plus 3, which is equal to 6, and 6 is divisible by 3, hence 123 is also divisible by 3. Take another example, 1, 2, 3, 4, and this is not divisible by 3 because sum of all the digits in the number 1, 2, 3, 4 is 10, which is not divisible by 3. So this is an interesting rule. Regardless of number of digits in a given number, this rule works. We can utilize this rule to solve this problem. I will explain why this rule is important. So what we can do now is add all the numbers from 1 to 5. It is because regardless of arrangement of numbers in any combinations, their sum remains constant. Sum of all numbers from 1 to 5 is 15, and sum of the digits in number 15 results in 6, that is 1 plus 5 equals 6. Since 6 is divisible by 3, regardless of the arrangement of 5 digits from 1 to 5, in whatever way, that number will be divisible by 3. Thus, there are more than 2 factors for any arrangement of digits. If the number has more than 2 factors, then the number is not a prime number. So thus, answer to this problem is none. None of the numbers are prime when the digits 1 to 5 rearranged in any distinct 5-digit numbers. So to summarize, the sum of numbers from 1 to 5 is 15 and therefore can be divisible by 3. Since the number of factors is more than 2, none of the numbers are prime. Hope you understood the solution. If you have not understood the solution, please watch it again and let me know if you have any questions. I will try to address as soon as possible. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Let me repeat the problem. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Can you solve this problem in 10 seconds? In this video, I am going to teach you how to approach these kind of problems and solve it in less than 10 seconds. Feel free to pause the video and try yourself before checking the solution. Do comment your answer in the comment section. I will explain 2 ways of approaching the problem. Let's consider the first method. According to the problem, door 1 empties the room in 3 minutes, door 2 in 6 minutes. Since door 1 takes 3 minutes to empty the room, here is how the relationship works. In 3 minutes, room gets empty. So for 1 minute, 1/3 room will get empty. Thus, door 1 can empty 1/3 of the capacity in a minute. For door 2, in 6 minutes, room gets empty. So for 1 minute, 1/6 room will get empty. Therefore, in 1 minute, both doors together can empty 1/3 plus 1/6, which is equal to half of the capacity. If half of the room gets empty in 1 minute, then it is obvious that it would take 2 minutes to empty the room with both doors. By following these simple steps, you can achieve the solution in minimal time. The trick with these sort of questions is to calculate how much they can do in a set common period of time, add it together and then find total time. Let's look into the second approach. In this approach, we will use the concept of LCM to find the solution. I will show you how to solve such problems without touching a pen or paper. We know that from the question, door 1 empties the room in 3 minutes, door 2 empties the room in 6 minutes. Let the volume of the room be the LCM of 3 and 6, which is equal to 6 liters. Therefore, door 1 removes 2 liters each minute, while door 2 removes 1 liter every minute. Together, they remove 3 liters each minute. Thus, time taken to empty the room equals 6/3, which is equal to 2 minutes. Here 6 is the total capacity and 3 is the total liters removed each minute. Thus, answer to the problem is 2 minutes. Hope this helps. You can use any of these methods to solve the problem in less than 10 seconds. Here the question is it possible to make 5 with only 2 2's using only elementary mathematical functions? Any mathematical function can be used, even roots is allowed to use. This can be achieved in numerous ways. Note that you are allowed to use only elementary mathematical operations and not advanced mathematical functions. I will explain 2 ways of achieving this, one through math way and the other through just logical way without using much math concepts. Through math way, we can achieve this by using math expression square root of 0.2 to the power minus 2. It is just take 0.2 and raise it to the power of minus 2 and then take the square root. Let's simplify the equation. 0.2 can be represented as 2 by 10. Now the expression becomes square root of 2 by 10 whole to the power of minus 2. And 2 by 10 whole to the power of minus 2 can be represented as 10 divided by 2 whole to the power of 2. Hence expression becomes square root of 10 divided by 2 whole to the power of 2. After solving this, we get square root of 25, which equals 5. This is the math way to find the solution. Now I will explain the logical way without using much math operations. Just consider the math expression square root of 22. So now mirror the second 2 to get the 25. This looks like square root of 25 and we know square root of 25 is 5. So this will work perfectly on digital display because 2 is the mirror of 5 exactly. So there are many correct answers to this question. I have explained 2 possible ways of finding the answer to this particular problem. Do comment your answer in the comment section. There are many complex ways where you can achieve the solution for this particular problem. I have explained the 2 simple ways how you can achieve the solution. One man has 81 cows. They give milk as per their numbers. Like 5th number cow gives 5 liters of milk. 10th number cow gives 10 liters of milk. The 81st number cow gives 81 liters of milk, and so on. That man has 9 sons and he want to give 9 cows each son and want each son get same liters of milk. So how he distribute those 81 cows to his sons? Let me simplify the puzzle. A man has 81 cows numbered 1, 2, 3 till 81. The beauty is that cow number 1 gives 1 liter of milk, cow number 2 gives 2 liters of milk, and so on. The man wants to equally distribute the cows among his 9 sons so that each one of them gets the same quantity of milk. So how he distribute those 81 cows to his sons? There are multiple solutions for this problem. In this video, I will explain the most appropriate way of solving this problem in steps. In the first step, let's find the total liters of milk from 81 cows, which is nothing but 1 plus 2 plus 3 plus and so on till plus 81. This is because as per the problem, each cow gives milk as per their number. Like the 5th number cow gives 5 liters of milk and the 10th number cow gives 10 liters of milk. The 81st number cow gives 81 liters of milk, and so on. If you observe this series, this is sum of n natural numbers where n here is 81. We know that sum of n natural numbers can be calculated using the formula n times n plus 1 divided by 2. Here n is 81. Substituting the value of n in the equation becomes 81 times 81 plus 1 divided by 2, which is nothing but 81 times 82 divided by 2 equals 81 times 41, which is 3321. Thus total liters of milk from 81 cows is 3321. In the next step, find how much milk should each son get. So each son should get 3321 divided by 9, which is equal to 369. Thus each son should get 369 liters of milk. In the next step, write the full sequence from 1 to 81 in a straight line and then add the extreme numbers in pairs. So here the first extreme numbers are 1 plus 81, second extreme numbers are 2 plus 80, third extreme numbers are 3 plus 79, and so on. So each pair will add up to 82. 4 such pairs will add up to 328. So why we are doing this is we are trying to bring the numbers closer to 369 because each son should get 369 liters of milk. So let's give 4 such pairs to each son, so 8 cows to each son. Each of them will have 328 with them. The orders look like this. Sun 1 will have the first 4 and the last 4 cows. Sun 2 will have the next 4 cows from either end, and Sun 3 will have the next 4 cows from either end, and so on. So after distributing the cows in this manner to all 9 suns, now there are 9 cows remaining, that is from 37 to 45. To get to 369, each of them need 41 more. So 41 is the 5th in sequence. So let's give 41 to the 5th sun. Now he has 328 plus 41, which is equal to 369. He is sorted. Now there are other 8 suns which requires additional cow in order to satisfy the condition. Now consider the remaining suns in pairs. Sun 1 and Sun 2 in pair, Sun 3 and Sun 4, Sun 6 and Sun 7, Sun 8 and Sun 9. First consider Sun 1 and Sun 2. If you give 37 to Sun 1, then he is 4 short. So swap a pair of cows between the two suns that has a difference of 4. So basically it is only 1 cow. So they swap their first cows. So the difference in the first cows will yield 4. After swap, so at this stage, Sun 1 have these following cows and Sun 2 have these following cows. So he needs a cow that covers for the 41. He was short in the first place and the 4 he gave to Sun 1. So the only option is 45. After giving cow with the number 45, this pair is sorted. So now take the next pair. Each of them are 41 short, but we only have cows which are plus or minus 3, plus or minus 2 and plus or minus 1 away from 41. So for this pair, let's do with plus or minus 3. So give 38 to Sun 3. It will now be 3 short. So swap a cow with a difference of 3. There are 6 possibilities. Let's go with 10 from Sun 3. A swap with 13 from Sun 4. Now Sun 3 is sorted and now the only option is 44 to Sun 4. So this pair is also sorted. For the next pair, there are again 41 short, but we only have cows which are plus or minus 2 and plus or minus 1 away from 41. If we do plus or minus 2 for this pair, then give 39 to Sun 6. It will now be 2 short. Swap a cow with Sun 7 with a difference of 2. So Sun 6 will now gain 2 and be equal to 369. Sun 7 will now need to make up for the 41 he needed anyway and the 2 he lost to Sun 6. The only option is 43, so this pair is also sorted. For the final pair, we only have cows 40 and 42 remaining with plus or minus away from 41. Give 40 to Sun 8, he will now be 1 short. Swap a cow with Sun 9 with a difference of 1. So Sun 8 will now gain 1 and be equal to 369. Sun 9 will now need to make up for the 41 he needed anyway and the 1 he lost to Sun 8. The only option is 42, so this pair is also sorted. Now all 9 suns have 9 cows and the total number of liters of milk each sun will get 369 liters. As you can see here, in this method alone, there are many combinations possible. Out of 200 fish in an aquarium, 99% are red. How many red fishes must be removed in order to reduce at 98%? This is an amazing math puzzle. Though looks simple, it is more trickier than we think. Let me explain the solution now. Initially, we know that total number of fish given is 200 and 99% are red, 1% non-red. Since only red fish must be removed, indirectly the question says that number of non-red fish must be constant. As per the question, initially 1% of fish are non-red, that is 1 over 100 multiplied with 200, which is equal to 2. Currently, the percentage of red fish is 99% in the aquarium full of 200 fishes. So total red fish is equal to 198 and non-red fish equals 2. Let's say after removing X red fish, the percentage of red fish becomes 98%. This can be represented in the form of equation like this: 198 minus X over 200 minus X equals 98 over 100. 198 minus X represents number of red fishes in aquarium after removing X red fish. 200 minus X represents total number of fishes remains in aquarium, which includes non-red fishes as well. RHS represents the percentage what we need to achieve. So let's solve this equation. After simplification, equation becomes 50 times 198 minus 50x equals 49 times 200 minus 49x. So x equals 9900 minus 9800, which is equal to 100. So now x equals 100. So it is tough to imagine that we will have to remove 100 fishes out of 198 red fish to bring the percentage down by 1% in a total of 200 fishes. The point to be paid attention is that when we are removing the red fish from the aquarium, we are decreasing the total number of fishes in the aquarium. So had we been converting every red fish taken out to a non-red fish and kept them back in the aquarium, only converting two red fish to non-red would have brought the percentage of red fish in the aquarium down to 98%. When something is subtracted from both numerator and denominator, the overall effect on the fraction is quite small, especially if numerator and denominator are large compared to the small amount subtracted from both. In this question, if you remove two red fish out of the 198 red, the new percentage is 98.989898, which is quite close to the original 99%. In fact, when a small amount delta is subtracted from both numerator and denominator, the change in the value of the fraction is a small number new delta, and the increase in delta is proportional to the increase in new delta, which is also the decrease in the value of the fraction. Here the fraction value decreases approximately by 0.005%. When we decrease the number of red fish by 1, this rate of change can be calculated by differentiating the above equation. And this is another way to solve this question. So we have to remove 100 red fish. So the number of red fish in total becomes 98%. It is quite unbelievable answer. The difference of percentage is 1, but the difference in number is 100. A man is twice as old as his son. 10 years ago, he was 3 times as old as his son. How old will his son be in 5 years' time? These kind of problems are easy to solve by forming equations with the given data. Remember, here our objective is to find the age of son. Suppose man is x years old, boy is y years old. Then since man is twice as old as his son, means x equals to y. So this is our first equation. 10 years ago, man's age is x minus 10. 10 years ago, son's age will be y minus 10. Since 10 years ago, man was 3 times as old as his son, which means that x minus 10 equals 3 of y minus 10. After solving this equation, x minus 10 equals 3y minus 30 and x equals 3y minus 30 plus 10. And after simplification, x equals 3y minus 20. Call this as equation 2. Now we have two equations. Now with these two equations, first we are trying to evaluate the value of y. So minus equation 1 from equation 2. That is x equals 3y minus 20 minus x equals 2y. We can cancel x here, so after simplification, y minus 20 equals 0, y equals 20. So current age of the son is 20 years. So in 5 years time, his age would be 25 years. Thus answer to this problem is 25 years. That is, the age of his son in 5 years time is 25 years. If you are asked to find the age of father, then substitute the value of y to any of the equations, then you can find the age of the father. Four black cows and 3 brown cows gives as much milk in 5 days as 3 black cows and 5 brown cows give in 4 days. Which color cow gives the most milk? So in this question, you are supposed to identify which color cow gives the most milk. Let me explain the solution now. The most appropriate way of solving this problem is by creating equations. Let the number of days be D, number of black cows be L, number of brown cows be R. According to the problem statement, 4 black cows and 3 brown cows gives as much milk in 5 days as 3 black cows and 5 brown cows gives in 4 days. This can be written in the form of equation like this. That is, 5D of 4L plus 3R equals 4D of 3L plus 5R. After simplification, equation becomes 20DL plus 15DR equals 12DL plus 20DR. On further simplification, 20DL minus 12DL equals 20DR minus 15DR. After simplifying further, 8DL equals 5DR and finally 8L equals 5R. It is clear from the equation that we would need 8 black cows to give the same amount of milk as 5 brown cows. Hence, brown cow gives the most milk. Which year has the same calendar as that of 2009? You are given with 4 options. Option 1, 2018, option 2, 2017, option 3, 2016, and option 4, 2015. Let me explain the solution now. Answer to this problem is 2015. Let me elaborate the solution now. See, to have the same calendar, two things should be matched. First, the first day of the year, and second, the year type, that is ordinary or leap year. Also remember, there is one odd day in one ordinary year and there are two odd days in one leap year. Given year in the problem is 2009 and 2009 is ordinary year, not leap year. Let the first day of year 2009 is X day. It means first day of 2010, which is next year, will be X plus 1 day, as there is one odd day in one ordinary year 2009. And it means first day of 2011 will be X plus 2 day, as there is one odd day in one ordinary year 2010, which is your previous year. Further steps will follow the same logic. Now consider the next year. The first day of 2012 will be X plus 3 day, as there is one odd day in one ordinary year 2011, which is your previous year. It means first day of 2013 will be X plus 5th day, as there are two odd days in one leap year 2012, which is your previous year. Again, it means first day of 2014 will be X plus 6th day, as there is one odd day in one ordinary year 2013, and the first day of 2015 will be X plus 7th day, as there is one odd day in one ordinary year 2014. So after every 7 days, the same day appears. So the first day of 2015 will be same as 2009. Since both are ordinary years, we can use the calendar of 2009 in 2015. Hence, answer to this problem is 2015. So this technique works for most of the calendar problems. Just remember these steps to get the correct answer in minimum time. Once you get the hold of these steps, you can find the solution in less than 10 seconds without pen and paper. John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. What is his earning on day 1001? We can solve this problem by using simple math concepts. Let me explain the solution now in detail. According to the question, John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. The thing that is unique about the question is that each day his earnings increased by 3. The pattern looks like an arithmetic progression. Hence, the earning each day are in arithmetic progression where each term has a common difference, that is, difference in each consecutive term is constant. An arithmetic progression is basically a sequence of numbers such that the difference of any two successive members is a constant. For example, the sequence 1, 2, 3, 4, etc. is an arithmetic progression with common difference 1. Similarly, the sequence 3, 5, 7, 9, 11 is also an arithmetic progression with common difference 2. If the sum is S, the sum S of the first n numbers of an arithmetic progression is calculated by the formula S equals n into 2a plus n minus 1 into d divided by 2, where a is the first term in the sequence, d is the common difference between terms, and n is the nth term in the sequence. We use this formula to find the solution for this problem since the pattern looks like an arithmetic progression. In this sequence, a equals 1, which is a first term in the sequence, d equals 3, which is the common difference between terms, and n equals 1001, which is the nth term in the sequence. So now solve for a equals 1, d equals 3, n equals 1001. Substitute the value of a, d, and n in the formula n into 2a plus n minus 1 into d divided by 2. After substituting, equation becomes s equals 2 plus 3 into 1000 into 1001 divided by 2. After solving, equation becomes s equals 3002 into 1001 divided by 2. After solving this, s equals $1,502,501. Thus, total earning of John on day 1001 is $1,502,501. By using this simple math technique, you can solve this problem easily. Let xyz be a 3-digit number where x plus y plus z is not a multiple of 3. Then xyz plus yzx plus zxy is not divisible by which of the following option? The options are 3, 9, 37, x plus y plus z. Let me solve this problem step by step. To solve this problem, one must know to represent generalized form of a 3-digit number. The general form of xyz equals 100x plus 10y plus z. Similarly, the general form of yzx equals 100y plus 10z plus x. And the general form of zxy equals 100z plus 10x plus y. And call these equations as 1, 2 and 3. So now add all these three equations. Adding three equations we will get xyz plus yzx plus zxy equals 100x plus 10y plus z plus 100y plus 10z plus x plus 100z plus 10x plus y. After solving this equation, so the result is xyz plus yzx plus zxy equals 111x plus 111y plus 111z, and call this equation as 4. Now simplify the equation 4. We will get xyz plus yzx plus zxy equals 111 into x plus y plus z. Now it is clear that 111 is the common factor. So xyz plus yzx plus zxy is divisible by 111. Also, xyz plus yzx plus zxy will be divisible by factors of 111. From the above options, 3 and 37 are factors of 111, hence these two numbers are divisible by 111. And as we can see in the last expression, x plus y plus z is also a factor of 111 into x plus y plus z. So only number which is not divisible in the given option is 9. Hence the solution to this problem is 9. See, by following these simple steps, you can solve these kind of problem in less time. My goal is to have $12. If I save $1 a month, then it will take me 12 months to save $12. If I save $2 a month, then it will take me 6 months to save $12. What if I saved $1.5 each month? How many months would it take me to save $12? Let me explain the solution now. Though riddle looks simple, but it is trickier. As soon as someone reads or listens to the question for the first time, most of the people thinks that the solution is 9 months. Because most of them tries to simplify the problem keeping number of months in mind, but more emphasis should be given to dollars. As per the question, for $12 to save, if I save $1 every month, then it will take 12 months. And if I save $2 every month, then it will take 6 months. If I answer it will take 9 months if I save $1.5 per month, then the answer is obviously wrong. Because 1.5 times 9 equals $13.5 and not $12. The best way to solve this problem is through math way. Just divide total dollars to be saved over dollars saved per month. Then we will get number of months. So if I save $1 per month, 12 over 1 equals 12 months. If I save $2 per month, 12 over 2 equals 6 months. And finally, if I save $1.5 per month, then 12 over 1.5 equals to 120 over 15, which is equal to 8 months. Thus, correct answer to this problem is 8 months. The flag shown here measures 100 centimeters by 60 centimeters. It is divided into 2 purple triangles and 2 pink triangles. What is the total area of the 2 purple triangles? Here our task is to find the total area occupied by 2 purple triangles in this flag-like diagram whose area is 100 centimeters by 60 centimeters. The flag is in rectangular shape. Here the length of the rectangle is 100 centimeters and breadth of the rectangle is 60 centimeters. Let me explain the solution now. In order to solve this problem, let's divide the flag into 4 rectangles. As shown here, a flag can be conveniently divided into 4 rectangles like this. Let's name these divided rectangles as A, B, C and D. If you observe each rectangles carefully, in each rectangle of the area of rectangle is purple. In rectangle A, of the area of rectangle is purple. Similarly, in rectangle B, C, D, of the area of rectangle is purple. Since in each rectangle of the area is purple, we can infer that of the area of the flag is purple. We know that area of rectangle equals length times breadth. Hence purple area is length times breadth over 2 since of the area of the flag is purple. Substitute the value of length and breadth in the formula. Now purple area equals 100 times 60 over 2 square centimeters. After solving this, we get 6000 over 2 square centimeters, and finally solving this we get 3000 square centimeters. Thus purple area in flag is 3000 square centimeters. We can easily solve this problem by conveniently dividing the flag into 4 rectangles. A student got twice as many sums wrong as he got right. If he attempted 48 sums in all, how many did he solve correctly? Let me explain the solution now. Let x be the number of sums student got right. Then the number of sums student answered wrong will be 2x. This is because as per the question, a student got twice as many sums wrong as he got right. And also it is mentioned in the question that the total number of questions is 48. So the equation becomes x plus 2x equals 48. After solving this equation, 3x is equal to 48 and finally x equals 16. Since x is number of correct answers, so student answered 16 right answers and 32 wrong answers. And this is the solution for this particular problem. If your approach is right, and you can solve this problem in less than 10 seconds. Six tigers can catch just 6 rabbits in 6 minutes. So how many tigers will be needed to catch 60 rabbits in 60 minutes? The immediate answer will be 60, but however, that is not the right answer. With mathematics, there is always something under the carpet. You have to look close. Let me explain the solution now. There is a general formula approach and logical approach to solve this problem. I will explain both. Let me explain the formula approach first. If M1 number of people can do W1 work in D1 days working T1 hours each day, and M2 number of people can do W2 work in D2 days working T2 hours each day, then the relation between them will be M1 times D1 times T1 over W1 equals M2 times D2 times T2 over W2. So here in this problem, the given information is 6 tigers can catch just 6 rabbits in 6 minutes. So what we are supposed to find is the number of tigers which is required to catch 60 rabbits in 60 minutes. So for this problem, there are only 3 variables. Hence formula can be written as M1 D1 over W1 equals M2 D2 over W2. Where M is number of workers, D is number of days, hours, minutes, seconds, and W is piece of work. Here catching rabbit is considered as work done by tiger. So M1 equals 6, D1 equals 6 and W1 equals 6. M2 is what we are supposed to find. D2 is equal to 60 and W2 equals 60. Now after substituting all the values, the equation becomes 6 times 6 over 6 equals M2 times 60 over 60. After solving this, we get m2 equals 6. Therefore, 6 tiger will be needed to catch 60 rabbits in 60 minutes, and this is the formula based approach. Sometimes the formula is not required in order to solve this problem. So let me explain the other ways to solve this puzzle without using formula. So one way is, so the given information, as we already know, that is 6 tigers can catch 6 rabbits in 6 minutes. According to this statement, 1 tiger can catch 1 rabbit in 6 minutes. In 60 minutes, each tiger can catch 10 rabbits. So each tiger can catch 10 rabbits in 60 minutes, but there are 6 tigers, hence 6 tigers can catch 60 rabbits in 60 minutes. So this is the straightforward approach. There is an alternative method. So consider again the given information, which is 6 tigers can catch just 6 rabbits in 6 minutes. So it is said in the question that 6 tigers can catch 6 rabbits in 6 minutes. If you multiply it by 10, the same tigers can catch 60 rabbits in 60 minutes. So the answer will be 6. So these are the logical ways of looking into the problem, and this is good way to solve the problem if the statements given are easy and variables are minimal. But if the given problem is difficult, then it is better to go with formula approach in order to avoid any kind of mistakes. One page is torn from a booklet whose pages are numbered in the usual manner, starting from the first page as 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following numbers? Is it 5, 6 or 7, 8 or 9, 10 or 11, 12? The most important thing about solving this problem is not just finding the correct solution, but to find it in less time, because that's what it demands in most of the competitive exams. So I am going to teach you how to solve this problem in less time. First of all, it is important to know one of the most important formula to solve these kind of problems, that is sum of n natural numbers. The formula is important here because the pages in the book are marked in the form of natural numbers, that is 1, 2, 3, 4, etc. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. For example, sum of first 10 natural numbers is calculated like this, that is 10 into 10 plus 1 divided by 2, which results in 55. In this case, n equals 10. Let's come back to the problem. Since page numbers are represented in the form of natural number series, without doubt, sum of all page numbers including torn page must be greater than 195. Now the task is to substitute for value of n till we get the number which is greater than 195. Now pick some random numbers. For example, first consider n equals 15. Sum of first 15 natural numbers is 15 into 16 divided by 2. This is after applying the formula n into n plus 1 divided by 2, which is 120 after solving. Since 120 is less than 195, we have to choose the other number which is coming close to 195, and it should be greater. So now consider n equals 20, which will result in 20 into 21 divided by 2. This equals to 210. This can be a right number which we are looking for, because for n equals 19, sum results in 190, which is less than 195. Hence 19 must be rejected. Thus number of pages in the book is 20, and now the task is to find the torn page. So now we need to subtract 195 from 210, which results in 15. So what are the two consecutive numbers those sum will result in 15? They are nothing but 7 and 8. Thus answer to the problem is 7 and 8. This is the approach one must follow to find the solution to these kind of problems. So I will show you one more problem which requires similar logic. So the question reads like this. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer. How will you find? Let me explain the solution. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. In this case, n is 50. So therefore, sum of all the numbers from 1 to 50 is 50 into 51 divided by 2. After solving, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integers present in the given series and subtract the sum from 1275. So this is the same procedure that we followed for the previous problem as well. So the difference between 1275 and this sum would give us the missing integer. Because 1275 is sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. So this is the logic to be used to find the missing number in the given series, provided that the series is positive natural numbers. And this is the logic to be applied in order to solve these kind of problems. There are some people on a train, 19 get off at the first stop, 17 get on. Now there are 63 people on the train. How many were on the train to begin with? Even though this puzzle looks very simple in the first view, it can have multiple interpretations. I am going to provide you 3 interpretations on how someone can think about this puzzle. This will help in understanding the approach required to solve these kind of puzzles. Simple way to look into the problem is through math way. As per the puzzle, people remaining on the train after addition and subtraction of passengers is 63. And people who got in from the first stop is 17. And the people who got off from the first stop is 19. Just do simple math, that is remaining passengers minus newly added passengers. This will fetch you the old passengers on the train. That is 63 minus 17, which is equal to 46. Now add old passengers plus passengers who got off from the first stop. That is 46 plus 19, which is equal to 65. So there must have been 65 people on the train in the beginning. This answer is accepted by many people, but since this is a brain teaser, we must be clear on the assumptions. Let's check the second way of looking into the problem. Let's go step by step now. So there are 63 people now on the train after the first station. It represents the combination of new and old passengers. The 17 people that get on the first station are new passengers and are not considered to be on the train to begin with. The 19 people that get off were old passengers but are no longer on the train. If none got off, the number of people that were on the train originally to begin with is 46 plus 19, or a total of 65. Now there are 63 people on the train. How many were on the train to begin with? This can be interpreted as how many old passengers remain on the train and those were on the train to begin with. The solution is the people that are on the train now are 63 minus 17, which is equal to 46, and these are the remnants of those who were on the train to begin with. Thus the answer is 46 as per this interpretation. Let's get into the final interpretation. So many people think that it is impossible to tell the answer to this puzzle with this information. Why they think like this is because the question doesn't state that when the 17 people got on the train, how many stops it has passed, or whether any more people departed or boarded in the meantime. Assuming the 17 people got onto the train at the first stop, when 19 people also departed and the train has not yet left the station, it would be 65 people on the train when it pulled into the first stop. However, to begin with, there would be no people on the train. The train would be empty before beginning any journey. This puzzle can have many interpretations like this. Do share your answer in the comment section. What is most important in these kind of puzzles is to think out of the box. This puzzle can have more than one correct answer, thus the expectation is the correct approach opted to solve this puzzle. The digits 0 to 9 can be rearranged into 3,628,800 distinct 10 digits numbers. How many of these numbers are prime? Let me elaborate the problem. First of all, it is important to understand what are prime numbers. Basically, prime number is a number that is divisible only by itself and 1. Example are 2, 3, 5, 7, 11, etc. The digits 0 to 9 can be rearranged into many distinct 10-digit numbers. Your task is to find all the prime numbers formed using the digits 0 to 9. Basically, you need a trick to solve this complex problem. It is not easy to find the solution to this problem unless you know the trick to find those numbers which are prime numbers. The trick which we can use here is divisibility rules. The most important rule which comes handy here is divisibility rule to find the number whether it is divisible by 3 or not. The rule states that a number is divisible by 3 only if sum of all the digits in the number is divisible by 3. For example, 123 is divisible by 3 because sum of all the digits in the number is 1 plus 2 plus 3 which is equal to 6, and 6 is divisible by 3, hence 123 is also divisible by 3. Take another example, 1234, and this is not divisible by 3 because sum of all the digits in the number 1234 is 10, which is not divisible by 3. This is an interesting rule. Regardless of number of digits in a given number, this rule works. We can utilize this rule to solve this problem. I will explain why this rule is important. So what we can do now is add all the numbers from 0 to 9. It is because regardless of arrangement of number in any combinations, their sum remain constant. Sum of all numbers from 0 to 9 is 45, and sum of the digits in number 45 results in 9, that is 4 plus 5 equals 9. Since 9 is divisible by 3, regardless of the arrangement of 10 digits from 0 to 9, in whatever the way, the number is divisible by 3. Thus, there are more than 2 factors for any arrangement of digits from 0 to 9. Now we know that if the number has more than 2 factors, then the number is not a prime number. Thus, answer to this problem is none. None of the numbers are prime when the digits 0 to 9 rearranged in any distinct 10 digits numbers. To summarize, the sum of numbers from 0 to 9 is 45 and therefore can be divisible by 3. Since the number of factors is more than 2, none of the numbers are prime. A stick 100 units long needs to be cut into 100 unit pieces. What is the minimum number of cuts required if you are allowed to cut several stick pieces at the same time? This is an interesting interview puzzle. Don't come to conclusion immediately. This requires a proper logical thinking to find the correct solution. Let me explain the solution now in step by step. The minimum number of cuts needed is 7. First, each cut can at most double the number of pieces you have. Therefore, you will need to make at least 7 cuts. This is because 2 power 6 equals 64, which is less than 100, while 2 power 7 equals 128, which is greater than 100. Let me explain now how 7 cuts suffices to cut 100 units long stick into 100 unit pieces. The following sequence of cuts works. In the first step, cut at 64 units from the left, that is, cut the stick into a length of 64 units and a length of 36 units. In the second step, lay your two pieces on top of each other, align at the left, and cut it 32 units from the left. It means in this step, lay the pieces so that the left ends line up and then cut so that you have three pieces of length 32 and one piece of length 4. In all future cuts, we will also start by laying the pieces so that their left ends line up. So in the third step, lay all your pieces on top of each other, aligned at the left, and cut at 16 units from the left, which means cut the pieces into 6 pieces of length 16 and 1 piece of length 4. In this step, we do not actually cut the piece of length 4. In the fourth step, lay all your pieces on top of each other, aligned at the left, and cut at 8 units from the left, which means cut the pieces into 12 pieces of length 8 and 1 piece of length 4. In the fifth step, lay all your pieces on top of each other, aligned at the left, and cut at 4 units from the left. Cut the pieces into 25 pieces of length 4. In the sixth step, cut the 25 pieces into 50 pieces of length 2. In the final step, cut the 50 pieces into 100 pieces of length 1. This procedure uses 7 cuts. To see that 6 or less cuts cannot solve the problem, note that a cut can at most double the number of pieces, so after 6 cuts, you cannot have more than 64 pieces. So answer to this puzzle is there are 7 cuts required to cut 100 units long stick into 100 units pieces. I believe that this algorithm of always cutting the largest power of 2, which is smaller than the largest pieces, will be optimal in general, not just for 100 pieces. A farmer has many goats and chickens. There are total 20 heads and 76 legs. How many goats and how many chickens does the farmer has? Let me repeat the puzzle. A farmer has many goats and chickens. There are total 20 heads and 76 legs. How many goats and how many chickens does the farmer has? This is a math puzzle. Correct method to solve these kind of puzzle is through creating equations. As per the puzzle, we know total number of heads are 20, total number of legs are 76. Let the number of goats be x and let the number of chickens be y. So each of them have one head and each chicken has 2 legs, whereas each goat have 4 legs. So total number of heads is heads of goats plus heads of chickens, which is equal to 20. So now the equation becomes x plus y equals 20, where x is number of goats and y is number of chickens. Also we know that from the puzzle, total number of legs is legs of goats plus legs of chickens, which is equal to 76. Now equation becomes 4 into x plus 2 into y, which is equal to 76. 4x is because x represents the goats and each goat have 4 legs. That's why it is 4x. 2y is because the y represents the number of chickens and each chicken has 2 legs. After simplifying, equation becomes 2x plus y equals 38 and call this equation 2. Now solve the equation 1 and 2 to find the value of x and y. Subtract equation 1 from equation 2. This will result in 2x plus y minus x minus y equals 38 minus 20. After solving this equation, the value of x is 18. Substitute the value of x in equation 1. Value of y becomes 2. Thus x equals 18 and y equals 2, which means number of goats equals 18, number of chickens equals 2. By following these simple steps, you can find the solution to these kind of puzzles in minimal time. There is an escalator and two persons move down it. A takes 50 steps and B takes 75 steps while the escalator is moving down. Given that the time taken by A to take one step is equal to time taken by B to take 3 steps, find the number of steps in the escalator while it is stationary. Let me explain the solution now. Let us say that the escalator moves at the rate of n steps per second. Let us also say A takes 1 step per second and B takes 3 steps per second. Let's solve this problem case by case. So in the case 1, when A is coming down, A will take 50 seconds to complete 50 steps. In 50 seconds, escalator would have moved 50 n steps. Total number of steps on the escalator can be represented as 50 plus 50n. So in the case 2, when B is coming down, B will take 25 seconds to complete 75 steps in 25 seconds. Escalator would have moved 25 n steps. In this case, total number of steps on the escalator can be represented as 75 plus 25n. So total number of steps on the stationary escalator is a constant. Combining case 1 and case 2, we can represent equation like this. 50 plus 50n equals 75 plus 25n. This is because number of steps are constant. After solving this equation, 25n equals 25, n equals 1. So total number of steps equals, consider the case 1. According to the case 1, the equation is 50 plus 50n. Now substitute the value of n, 50 plus 50, which is equal to 100. So the total number of steps is equal to 100. Anand has 3 daughters. His friend Ravi wants to know the ages of his daughters. Anand gives him first hint. The first hint is the product of their ages is 72. Ravi says this is not enough information. Then Anand gives him a second hint. The second hint is the sum of their ages is equal to my house number. Ravi goes out and look at the house number and tells, I still do not have enough information to determine the ages. Anand admits that Ravi cannot guess with these hints, and then he gives him the third hint. The third hint is the oldest of the girls likes strawberry ice cream. Now Ravi able to guess after the third hint. Can you guess what are the ages of 3 daughters? Let's check the solution now. To start with, list out all possibilities to get 72 from product of 3 different ages. Because the first clue given is that the product of 3 daughter ages is 72. So here are all possibilities to get 72 from product of 3 different ages. Since there are multiple possibilities, it is difficult to guess the ages of 3 daughters with this specific hint. Let's check the second hint now. The second hint is the sum of their ages is equal to my house number. So we have already possibilities of product of 3 daughters age. Here are sum of their ages. We have already calculated the product. Now let's see what are the sum of their respective ages. If you carefully observe in this particular detail, all sums are unique except 14. So the age sum must have been 14. Otherwise Ravi would have guessed the ages from hint 2 itself. So we have two possible combinations to get sum 14, that is with 2 plus 6 plus 6 which is equal to 14 and 3 plus 3 plus 8 which is equal to 14. Since there are two possibilities, it is difficult to guess the ages of three daughters here also. So let's check the third clue now. So the third clue says that the oldest of the girls likes strawberry ice cream, which clearly says that Anand has an oldest girl and not two. That means the oldest daughter cannot be of two numbers. Hence we can rule out 2 plus 6 is equal to 14 option, because oldest daughters are 2 in this case. So the ages must be 3, 3 and 8, and that's the solution. So ages of 3 daughters are 3, 3 and 8. How many diagonals can be drawn by joining the vertices of an octagon? Let me repeat the question. How many diagonals can be drawn by joining the vertices of an octagon? Let me explain the solution now. Octagon is 8-sided polygon. If you draw an octagon, select one vertex and construct each diagonal from this vertex. You will see there are 5 such diagonals. Thus, for each of the 8 vertices, you can draw 5 diagonals, and hence there can be 5 times 8, which equals to 40 diagonals. But remember, each diagonal is counted twice, once from each of its ends. Thus, there are 20 diagonals in a regular octagon. So to summarize, each point on the octagon can be connected to 8 minus 3 points. This is because you cannot draw diagonal by joining the adjacent vertex. Hence we need to subtract 3 vertices. So each point can form 5 diagonals. So we get 40 in all. However, this includes similar pairs, that is 1 6, 6 1, 2 4, 4 2, etc. So we divide this by 2. So answer is 20. We can generalize the solution for any polygon. If n is the number of vertices, we can derive the formula. To draw a diagonal, you have to select 2 vertices out of n. But you cannot draw diagonal by joining the adjacent vertex. Hence, number of diagonals can be calculated using the technique of combination. Number of diagonals equals nc2 minus n, where n is the number of sides of the polygon. So for octagon, n equals 8. Hence, number of diagonals equals 8c2 minus 8. So 8c2 is nothing but 8 times 7 divided by 2 times 1. So after solving this, the expression becomes 28 minus 8, which is equal to 20. There is another way which is easier compared to this technique. The number of diagonals of an n-sided polygon can also be calculated using the formula n times n minus 3 over 2. For example, in a square, there are 4 vertices. In this case, n becomes 4. Hence, after substituting, number of diagonals possible in square is 4 times 4 minus 3 over 2, which is equal to 2. Similarly, in octagon, there are 8 vertices. Hence, n is 8. After substituting, expression becomes 8 times 8 minus 3 divided by 2. After solving this expression, the solution is 20. Just remember this formula, that is n times n minus 3 over 2. You can find number of diagonals in any polygon in less than 5 seconds. Seven men have 7 wives. Each man and each wife has 7 children. What is the total number of people? This is not so much of riddle, it's actually more of a math problem, and if you sit down with a pen, paper and calculator, you can probably work it out. But your answer will differ depending on how you read the question, which is what makes it so different. There are actually a few possible answers to this riddle depending on how you read the question, and no one can agree on which one is correct. Let me explain three possible solutions to this problem. One possible answer is 63. But how do you get there? Let me explain now. Well, if 7 men have 7 wives, that means they have 1 wife each. So that will be 7 plus 7 equals 14. Then each wife has 7 children, so that will be 7 times 7, which is equal to 49. Next, we add the children to the men and wives and get 49 plus 14 equals 63. So the total number of people according to this reading is 63. But what if you got the answer 399? You are not wrong, you just read the question differently. According to this reading, if each of the 7 men had 7 wives each, that would be 7 times 7, which is equal to 49 wives. Then we need to add on the 7 men, so that is 49 plus 7 equals 56. Next, we have to work out the number of children, which is 7 times 7 times 7, which is equal to 343. Then we add the number of men and wives to the children and get 343 plus 56, which is equal to 399. Thus, the total number of people is 399 according to this reading. Or did you work the answer out to be 21? That could also be correct. Here is how we get answer 21. If 7 men have 7 wives, that simply means there are 7 coupled. So that is 7 plus 7 equals 14. Then if each couple has a child, that is 14 plus 7 equals 21. So the total number of people is 21 according to this reading. See, this problem can have other solution as well. Do share your answer in the comment section. Susan and Lisa decided to play tennis against each other. Riddle is a riddle that is trending on social media, including Facebook, Instagram, and WhatsApp. Share this riddle and challenge your friends and family. Watch this video to know the correct answer to this riddle. Riddle states that Susan and Lisa decided to play tennis against each other. They bet $1 on each game they played. Susan won 3 bets and Lisa won $5. How many games did they play? Let me explain the solution now. The answer to this riddle is 11. They played 11 games. Let me explain the solution in detail. According to the riddle, Lisa won $5 and Susan won 3 bets. Susan won 3 bets, meaning Lisa lost 3 games, that is minus $3. So Lisa had to win 3 additional games to break even, that is to become 0. So Lisa lost 3 games and won 3 games. So that is equal to minus $3 plus $3, which is equal to 0. This results in total number of games to 6 at this point of time. Also at this situation, Lisa and Susan have $0 left. But we know that according to the riddle, Lisa won $5. Then Lisa had to win 5 more games to win $5. So total number of games equals 3 plus 3 plus 5, which is equal to 11. Hence answer to this riddle is 11 games. There is an equilateral triangle and 3 bugs are sitting on the 3 corners of the triangle. Each of the bugs picks up a random direction and starts walking along the edge of the equilateral triangle. What is the probability that none of the bugs crash into each other? Here in this puzzle, every bug has 2 choices. Pick either of 2 edges, go through the corner on which bug is initially sitting. If you have come up with the fact that the bugs can avoid the collision only when they decide to move in the same direction, be it clockwise or anti-clockwise, you have already solved off of it. In any other way, the bugs will definitely run into each other. Now the bugs can move either clockwise or anti-clockwise. The probability of choosing a specific direction is then 1 over 2. We will utilize the simple equation of probability to find out our answer. The probability of no collision equals probability of the bugs move in clockwise direction plus probability of the bugs move in anti-clockwise direction. Probability of the bugs move in clockwise direction is 0.5 times 0.5 times 0.5. This is because there are 3 bugs and each bug have 2 options, either moving in clockwise or anti-clockwise direction. Similarly, the probability of the bugs move in anti-clockwise direction is 0.5 times 0.5 times 0.5. This is because there are 3 bugs and each bug have 2 options, either moving in clockwise or anti-clockwise direction. Hence, probability of no collision equals 0.5 times 0.5 times 0.5 plus 0.5 times 0.5 times 0.5, which is equal to 0.25. Thus, the probability that the bugs won't collide into each other is 0.25 or 1 over 4 or 1/4. In a conference, out of a total 100 participants, 70 are Americans. If 60 of the total participants are vegetarian, then which of the following statements correct? The first statement is at least 30 American participants are vegetarian. Statement 2, at least 10 American participants are non-vegetarian. You are supposed to find the correct statement after analyzing the problem. There can be both statements correct or neither of the statements can be correct. According to the question, there are 100 participants and out of 100, 70 are Americans, so non-Americans will be 30. There are 2 statements given and we are supposed to find which statement is correct. Let's analyze the first statement. The first statement is at least 30 American participants are vegetarian. To check this statement is correct or not, let's try to minimize the number of American vegetarians. For that, we have to maximize the number of non-American vegetarians. Out of 30 non-Americans, at max, all can be vegetarian. Still 30 vegetarians remain which will fall under American category because there are total 60 participants who are vegetarians. So at least 30 Americans will be there who will be vegetarians. So if 60 of the total participants are vegetarians, assuming all 30 non-Americans to be vegetarian, at least 30 American participants are still vegetarian. So without any question, first statement is correct. Now get into the second statement. The second statement is at least 10 American participants are non-vegetarian. To check this statement is correct or not, let's try to maximize the number of American vegetarians. Out of 70 Americans, all vegetarians, that is 60 can be Americans. So at least 10 Americans will be there who will be non-vegetarians. The number can increase depending on number of vegetarian Americans. So assuming all 30 non-Americans to be non-vegetarian, at least 10 American participants must be non-vegetarian. So second statement is also correct. Hence, after analyzing the problem statement carefully, we can conclude that both statements are correct. If 2 equals 6, 3 equals 12, 4 equals 20, 5 equals 30 and 6 equals 42, what does 9 equals to? This question is basically the application of patterns and sequences. These types of question can be easily solved if one tries to observe the pattern being followed. If you observe the pattern carefully,
In each set, the integer before the equal sign is multiplied by its consecutive next integer greater than it, and the result is on the other side of the equal sign. For example, in the first set, the integer before the equal sign is 2, which is multiplied by its consecutive next integer greater than it, which is 3, and the result is 6, which is on the other side of the equal sign. Similarly, in the second set, the integer before the equal sign is 3, which is multiplied by its consecutive next integer greater than it, which is 4, and the result is 12, which is on the other side of the equal sign. Applying this pattern, series looks like this. By observing, the answer to this pattern is 90. So the 90 is the correct answer to this particular problem, and it can have different answer depending upon the pattern which satisfies to this problem. There are multiple patterns which satisfies this problem. I will explain one another pattern. Here in the problem, the first number is what we are given and the second number is what is hidden. Here by taking a close look, we will see that the pattern is decoded as right hand side equals x plus x square, where x is the number in the left hand side. So by applying this pattern, we can actually see the things happening. For example, in the first set, the integer before the equal sign is 2, hence x is 2. After applying the value in the pattern, right hand side is 2 plus 2 square, which is nothing but 6. Similarly, in the second set, the integer before the equal sign is 3, hence x is 3. After applying the value in the pattern, right hand side is 3 plus 3 square, which is nothing but 12. Applying the same pattern to 9, solution is 9 plus 9 square, which results in 90. The answer could have been different if you take pattern alternatively. Do share your answer in the comment section if you found different pattern which satisfies here.
Three teachers get on the school bus. One teacher has 16 students. The other two teachers have 12 students combined. How many people are on the bus? There can be multiple interpretation to this puzzle. Do share yours in the comment section. The easiest and probably the most correct answer is 3, since we are not told of a bus driver or if the students get on the bus. But otherwise it would work as follows. There are 16 students for one teacher and two teachers have 12 students combined. So number of students are 16 students plus 12 students, which is equal to 28 total students. 28 total students plus 3 teachers equals 31. So the answer is 31 if you can assume there is no supervisor for the trip and no bus driver. If there is a bus driver, then you need to factor in one more person and you would get 32 people. If you need to factor supervisor, then there is no way to answer because we do not know the number of supervisors there might be. If you assume there is one for each of the 28 students, then you add another 28 to the 31 or 32 to get 59 or 60 people in total. So there is no single correct answer to this riddle. Solution depends on interpretation. Most accepted answer to this riddle is 3 because there is no mention in the riddle that bus driver or the students get onto the bus, but it is clearly mentioned that 3 teachers get onto the bus. Observe the given multiples of 37. 37 times 3 equals 111, 37 times 6 equals 222, 37 times 9 equals 333, 37 times 12 equals 444. Find the product of 37 times 27. You are given with 4 options. Option A is 999, option B greatest 3-digit number, option C either A or B, option D smallest 3-digit number.
By observing the given question, it is evident that 4 multiples of 37 are given and the fifth multiple, which is 37 times 27, should be found. If observed carefully, it can be noticed that a series is being formed at the right hand side of every equation. Henceforth, it can be anticipated that our answer will also be present in the same series. Let me explain the solution in step by step. First, let's split the given equations to find the trend, which implies that 37 times 3 equals 111 can be written as 37 times 3 times 1, which is equal to 111. Similarly, 37 times 6 equals 222 can be written as 37 times 3 times 2, which is equal to 222. And 37 times 9 equals 333 can be written as 37 times 3 times 3, which is equal to 333. And 37 times 12 equals 444 can be written as 37 times 3 times 4 equals 444. Coming back to our question, we need to find 37 times 27. We know that 27 can be written as the product of multiples of 3, which implies 27 equals 3 times 3 times 3. Therefore, 37 times 27 can be modified to 37 times 3 times 3 times 3. Looking at our above equations, we already have 37 times 3 times 3, which is equal to 333, which implies 37 times 27 equals 37 times 3 times 3 times 3. And 37 times 27 becomes 333 times 3. And finally, after solving this, 37 times 27 equals 999. We have now calculated the value of 37 times 27, which is 999. Let's tally our answer with the given options. The first option, A, is 999, which matches with our answer. Hence, option A is correct. The second option, B, says the largest 3-digit number, which is 999. And the answer we obtained is 999 too. Hence, option B is correct too. Option C, that states both option A and option B are correct, is true as the question requires a single option to be the correct answer. So the correct answers are option A and B. While solving questions like these, we should not always first jump into the solution by calculating the whole value like multiplying it. We should always try for a logical approach to the question by clearly looking at all the options and finding a trend in the given question. All the 4 options should be checked thoroughly. So there is a similar question which states that how can you get the numbers 111, 222, 333 and 444 by multiplying two numbers with one of these numbers being always the same. So you can pause and try before checking the solution. Let me explain the solution now. So 111, 222, 333 and 444 each have 111 as a factor. 111 itself factors to 37 times 3. We knew it was divisible by 3 because its digits sum to 3. The rule of divisibility by 3 states if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Some examples of numbers divisible by 3 are the number 85,152 is divisible by 3 because the sum of its digits 8 plus 5 plus 1 plus 5 plus 2 equals 21 is divisible by 3. So the solution to this problem is 111 can be represented as 1 times 111 or 3 times 37. 222 can be represented as 2 times 111 or 2 times 3 times 37. 333 can be represented as 3 times 111 or 3 times 3 times 37. Finally, 444 can be represented as 4 times 111 or 4 times 3 times 37. So you can either go the obvious and straightforward route of having one of the two numbers be 111, then the second number is 1, 2, 3 and 4 respectively. Or you can note that 37 is common to the factorization of all 4. Use that. There are two possibilities here. In the first case, you are looking for a second number of 1 times 3, which is equal to 3. 2 times 3 equals 6. 3 times 3 equals 9. And 4 times 3 equals 12. But there is one more. 3 is also common to all 4. Now you need a second number. That is 1 times 37 equals 37. 2 times 37 equals 74. 3 times 37 equals 111. 4 times 37 equals 148. So that's the whole list. So how do you do it? First of all, find the factors common to all 4 numbers and use one of them or any combination of them. And then for each of the 4, use the residue multiplied together for each of the second numbers. By following these simple steps, you can achieve the solution in less time. In the addition given here, all digits have been replaced by letters. Equal letters represents equal digits and different letters represent different digits. Can you find the digits which represents letters, and what does the complete addition looks like in digits? Let me explain the solution now. There are 3 most important points one must remember before beginning to solve these kind of math problems. Number 1. Since there are 4 numbers in each column, maximum sum possible using 4 digits is 36. That is by using 4 nines. And number 2, since the maximum number possible using 4 digits is 36, maximum remainder possible in each column is 3. Number 3, maximum sum possible in each column is 39, that is after adding remainder to the maximum sum 36. Now we have to apply these 3 most important rules to find the value of each letter. Also, we must make a decision on how to start, whether to start from the right or left columns. Let's observe the problem carefully and see the answer. According to the answer, there is a repeated number which suggests that it is a good thing to start from the left columns. Here in this problem, A is repeated. Possible digits for A is 0, 1, 2, 3. Why? It is because we know that maximum sum possible using 4 digits is 39, including remainder. So A cannot be more than 4. We can eliminate 0 because 0 cannot be a digit to A. So now consider if A equals 1. If A equals 1, then A is 1, 1. In the last column, letter A is repeated thrice. Sum of 3 A's will yield 3, and to get the value 11, sum of B and remainder must be 8. Now possible combinations that satisfy the value of 8 is 0, 8, 1, 7, 2, 6, 3, 5, where first digit is remainder and second digit is the value of B. Only 2 digits that satisfy the given addition is 2, 6. You can try other possibilities, it is not definitely going to satisfy the condition. Thus the value of A is 1 and the value of B is 6. Now we have the value of A and the value of B. Now the whole calculation gets simplified. Now use the value of A and B in the right columns. Consider the first column. Value of rightmost column after substituting the values of A and B is 1 plus 1 plus 6 plus 1, which is equal to 9. Hence value of H is 9. Now consider the next column. After substituting the value of A and B in the second column, the expression becomes 6 plus 1 plus 6 plus 1 equals to 14. Thus the value of D is 4 and 1 is the carry forward to the next column. For the next column, expression becomes 1 plus C plus 1 plus 6 equals x6. Expression includes remainder and x will be the remainder for the next column. After solving, expression becomes 9 plus C equals x6. The only number which satisfies for C for this expression is 7 and x will be 1, and that is the carry forward for the next column. Now get into the next column. Now we have the value of A, we have the value of B and the value of C. Now apply the value of A, B, C for the next column. Now the expression becomes 1 plus 7 plus 4 plus e plus 4 equals xg. There are multiple digits which satisfies for the value of e. Let's consider the least number which satisfies the expression. The least number would be 2. Sum will be 18. Thus value of g is 8 and the remainder will be 1. Now after substituting the value of b in the next column, the value of f will be 5. So the complete addition looks like this. This is hard math puzzle and requires a systematic approach to find the solution. If you follow these simple steps, whichever I have explained in this video, will definitely help you to solve these kind of problems in a minimum time. There are 14 numbers here. 7 numbers are in red and other 7 numbers are in blue color. We have to pair off the red and blue numbers so that each blue number is divisible by the red number that it is paired with. After that, divide each blue number by the red number that is paired with. Can you find what is the sum of all the integers that you obtained in this way? So this problem can be divided into 3 steps. First step is to pair off the red and blue numbers so that each blue number is divisible by the red number that it is paired with. Second step is to divide each blue number by the red number that is paired with. Third step is to find sum of all the integers that you obtained in the second step. So this is an interesting problem. You may need to think for a while before getting into the correct solution. Feel free to pause the video and give it a try before checking the solution. Let's solve this in steps. In the first step, we have to pair off the red and blue numbers so that each blue number is divisible by the red number that it is paired with. The only way to pair off the red and blue numbers so each blue number is paired with a red number that it is divisible be shown here. So here 1 is paired with 31, 2 is paired with 34, 3 is paired with 33, 4 is paired with 32, 5 is paired with 30, 6 is paired with 36, 7 is paired with 35. Second step, let's divide each blue number by the red number that it is paired with. So 31 over 1 equals 31, 34 over 2 equals 17, 33 over 3 equals 11, 32 over 4 equals 8, 30 over 5 equals 6, 36 over 6 equals 6 again, 35 over 7 equals 5. Finally, third step is to find sum of all the integers that you obtained in the second step. So the numbers obtained in the second step are 31, 17, 11, 8, 6, 6 and 5. And its sum is 84. The solution to this problem is 84.
Between the numbers 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19, what 5 numbers will make 50? Let me explain the solution now. So the given question is what 5 numbers out of these given numbers we can take and add them to get 50 without repeating any number. Before proceeding, it is important to understand that it is impossible to get the value 50 using 5 numbers mentioned here, since the sum of any odd number of odd numbers is itself always odd. It would be impossible to pick 5 odd numbers from this list and get 50, which is basically an even number. Let me simplify. All the numbers mentioned in the question are odd numbers. The sum of 5 odd numbers will always be odd. This is because sum of any odd numbers of odd numbers is itself always odd. So there cannot be any possible way in which you can add any 5 numbers from the list given to get a sum equal to 50, which is even. But there are several ways to achieve by performing certain modifications, that is by using certain mathematical operations. One way to do is like this: 13 plus 19 plus 5 plus 7 plus 3, perform factorial mathematical operation on 3. So we know that 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. Now this will result in 50. So there can be other ways in which you can achieve the solution. Do share your answer in the comment section. Just remember, you can only perform addition operation with certain mathematical modifications. If the same question is asked with little modification, like use 5 numbers in the given list of numbers to make 50, but you can add, subtract, multiply, but you are not supposed to repeat numbers. This is pretty simple compared to the previous scenario. By using multiplication operation, we can have multiple answers. One way to achieve is like this: 1 times 3 plus 11 plus 17 plus 19. This will result in 50. Other possibilities are 3 times 5 plus 9 plus 11 plus 15. This also results in 50. 1 times 9 plus 11 plus 13 plus 17 equals 50. 3 times 7 plus 9 plus 5 plus 15 equals 50. 1 times 7 plus 13 plus 11 plus 19, which is again equals to 50. So there are multiple answers. If the condition is given that, you can use addition, multiplication and subtraction operations. In this image, you have to identify the missing number that will replace the question mark. An active mind can solve this riddle within 30 seconds. You are required to look at the matrix carefully before answering the question. In this image, you are supposed to identify the number belonging to each shape, like triangle, circle, square, and diamond. In this brain puzzle, you need to count the number belonging to each shape and then identify which number will replace the question mark. In the first row, there are 4 triangles. Through the first row of the matrix, it can be derived that sum of 4 triangles equals 32. 32 over 4, which is equal to 8. Hence, the value of triangle shape is 8. In second row, there are 2 triangles and 2 circles, and we already know the value of triangle, which is 8. After replacing the value of triangle, expression becomes 8 plus 8 plus 2 circles, which is equal to 28. It indicates that circle equals 6. At this time, third row cannot be used to calculate the values of other 2 shapes because there are 2 unknown values. Hence, let's consider third column. In the third column, we already know the value of triangle and circle. After substituting the value of triangle and circle, it indicates that diamond equals 4. Now consider third row and substitute the value of circle, diamond and triangle, which indicates that square equals 10. Now we know all the values which is required to find the value of first column. The value of triangle is 8, the value of circle is 6, the value of diamond is 4, and the value of square is 10. To identify the value of first column, we need the value of square, circle, and triangle. After substituting the value of triangle, square, and circle, the expression will be 8 plus 8 plus 6 plus 10, which is equal to 32. So the answer to the puzzle is 32. Using creative and analytical thinking will help you to derive answers in such brain teasers. This puzzle was tricky but simple as it needs less time and brain power to solve. But it sure feels great when you figure out the answer in a few seconds. Here in this problem, there are different geometrical figures and each geometrical figure is represented with some numbers. But there is a missing number in one of the squares. There is an interconnected logic and our task is to find the logic and identify the missing number. Let me explain the solution now. Whenever you see this kind of geometrical mixed up puzzle, first task is to arrange these figures correctly. Let's place all triangles in the first row and circles in the second row and squares in the third row. Now let's check whether we can perform some basic mathematical operations on the numbers in each row. To begin, let's add the numbers in each row. In the first row, sum of numbers in triangles is 4 plus 11 plus 18, which is equal to 33. In the second row, sum of numbers in the circles is 5 plus 12 plus 16 equals 33. So according to the logic, sum of numbers inside the same geometrical figures is 33. So in the final row, let the missing number be x. Hence the equation becomes 8 plus 19 plus x equals 33. After solving for x becomes 6. Thus the missing number is 6.
There are 3 circles presented here. There are 3 numbers embedded in each circle. We are supposed to find the missing number in the third circle. Observe the numbers carefully and there is a relation between the numbers. Can you find the missing number? First of all, finding the relation between the numbers is not easy since it is not straightforward. By solving more and more such problems and through practice, we can solve these kind of problems in minimum time. So coming back to the problem, the logic here is the left number multiplied by 5 gives the total of the other two. So let's consider the first circle. Here left number is 27 and sum of other two numbers is 56 plus 79, which equals to 135. Now multiply the left number, that is 27, with 5, which yields 135, which is nothing but the sum of other two numbers in the right side. So in the first circle, 27 times 5 equals 56 plus 79, which is equal to 135. This is the logic for this particular problem. So let's consider the second circle. So left number is 23 and sum of other two numbers is 88 plus 27, which is equal to 115. Now multiply the left number, that is 23, with 5, which yields 115, which is nothing but the sum of other two numbers in the right side. So 23 times 5 equals 88 plus 27, which is equal to 115. So apply the same logic in the third circle. So we have left number and we are supposed to find the missing number in the right side. Here the equation becomes 16 times 5 equals 56 plus x, where x is the missing number. Solving for x becomes 16 times 5 minus 56, which equals to 80 minus 56, which is equal to 24. So thus the value of x is 24. So 24 is the missing number in the third circle. If you have figured it out the solution, then it is great. Else nothing to worry. Keep practicing more and more such kind of problems.
If 29 minus 1 equals 30, 9 minus 1 equals 10, 14 minus 1 equals 15, based on this logic, can you find the value of 11 minus 1? In order to solve this problem, one should have the knowledge on representation of numbers in Roman numerals. Roman numerals are written using 7 different letters. They are I, V, X, L, C, D and M. They represent the numbers 1, 5, 10, 50, 100, 500 and 1000. We use these 7 letters to make up thousands of others. For example, the Roman numeral for 2 is written as I. The number 12 is written as XII, which is just X plus II. If we take this a step further, the number 27 is written as XXVII, which when broken down looks like XX, which is 20, plus V, which is 5, plus II, which is 2, summing all will result in 27. The Roman numeral for 3 is written as III, but 4 is not written in the same way. Instead, the subtractive principle is used. The number 4 is written as IV. Here we have I before V, and because the smaller number is before the larger number, we know that we have to subtract here, making IV 4. The same principle applies to the number 9, which is written as IX. Let's use the same principle to solve this math puzzle. In the first equation, Roman equivalent of 29 is XX, and Roman equivalent of 1 is I, and Roman equivalent of 30 is XXX. If you observe carefully here, actual subtraction is not performed. Instead, Roman numeral I, which is a second numeral, is removed from first numeral, which results in XXX, which is RHS of the equation. Similarly, in the second equation, 9 is represented as IX and 10 is represented as X. Here again numeral I, which is a second numeral, is removed from the first numeral, which results in X, which is RHS of the equation. And finally, in the third equation, 14 is represented as XIV and 15 is represented as XV. Here again numeral I, which is a second numeral, is removed from first numeral, which results in XV, which is RHS of the equation. So now apply the same logic for the final equation. Roman equivalent of 11 is XI. Now remove I from the numeral, which results in X. Thus the solution for this puzzle is X, and its equivalent decimal representation is 10. Thus the answer to this puzzle is 10. If you have the knowledge how to represent the numbers in Roman numerals, then solving this puzzle is very simple. This is what you have for equation, and following are the numbers that you can use to fill in the brackets. They are 1, 3, 5, 7, 9, 11, 13 and 15. You can repeat the number if required. The resulting sum should be 30. Here is the solution. Solution can be achieved in multiple ways. In this video, I will explain 2 different ways to achieve the solution. So the main issue here is that all the given numbers are odd, and an addition of odd numbers for odd number of times will result in odd number. There are 5 brackets, which is basically an odd number, and all the numbers which are given are odd numbers, and hence the addition of odd numbers for odd number of times obviously will result in an odd number. So in no way will you get an even number like 30 by adding these odd numbers, but we can apply other mathematical operations inside brackets and get the answer. This is the logic to be used in order to achieve the solution for this particular math puzzle. So in method 1, we can achieve the result of 30 by using the minus operator or subtraction operator inside the brackets with the digits. This is how we can achieve the solution using subtraction. Fill the first bracket with 15 minus 9, second with 13 minus 7, third with 7 minus 1, fourth with 9 minus 1, and the last with 13 minus 9. If you solve inside the brackets, you will get the following equation, that is 6 plus 6 plus 6 plus 8 plus 4, which equals to 30. This is how we can achieve the solution using the method 1, using the subtraction operator. In the method 2, the result of 30 can also be achieved by using the factorial of number. Before checking this method, it is important to understand some basics of factorial. So factorial of a non-negative integer is multiplication of all integers smaller than or equal to n. For example, factorial of 3 is 3 into 2 into 1, which is 6, and factorial of 6 is 6 into 5 into 4 into 3 into 2 into 1, which is 720. So let's back to the puzzle. Since factorial of 3 is equal to 6, if we add 3 factorial 5 times, it will result in 30. Hence, fill all brackets with 3 factorial, which results in 30, and this is how we can achieve the result by using the method 2. There are more ways to solve this puzzle. Share if you know the different method in the comment section. One rabbit saw 6 elephants while going to the river. Every elephant saw 2 monkeys going to the river. Every monkey has 1 parrot each. How many animals are going towards the river? Although this puzzle has got innumerable different answers, however, I will explain the most common one along with the most logical explanation accompanying it. There is one more interesting variation of the same riddle which I will explain in the later part of the video. Many people have answered 3, citing the argument that parrots, being birds, are not animals. Let me explain how. One rabbit saw 6 elephants while going to the river. Therefore, it is only the rabbit who is going to the river and not elephants. Now, every elephant sees 2 monkeys. This implies that every elephant witnesses 2 same monkeys who are going to the river. The next line says that every monkey has 1 parrot each. A parrot is considered as bird, not an animal. So the total number of animals going to the river is 3, that is 1 rabbit and 2 monkeys. And this is the most common answer and logical explanation for this particular riddle. Now let's check the different variation of the same riddle. One rabbit saw 6 elephants while going to the river. Every elephant saw 2 monkeys going to the river. Every monkey has 1 parrot each. How many of the animals went to the river? Even though it sounds same as previous one, but this riddle is not as simple we think. If you observe the riddle, there is a slight difference in the riddle, but this slight difference will result in a different solution. Let's check the solution now for this particular riddle. Watch the complete video for clear understanding of the solution. Let me explain now. First of all, break the riddle into multiple statements. The statement 1 is, a rabbit saw 6 elephants while going to the river. It is clearly stated that the rabbit saw the elephants while going to the river, hence it is confirmed that the rabbit was going to the river. That is, one animal going to the river. But the statement does not mention whether the elephants were going to the river or elsewhere. Actually, it is not even mentioned that the elephants were going anywhere. They could be going somewhere else or just standing. It doesn't matter. According to the first statement, it is confirmed that one animal, that is rabbit, is going to the river. Let's move on to the next statement. The statement 2 is, every elephant saw 2 monkeys going to the river. It is clearly stated monkeys going to the river, so it is clear that the monkeys were going to the river. Also, it is mentioned that every elephant saw 2 monkeys. It is not clear whether every elephant saw the same 2 monkeys or different ones. But one thing is clear, that at least 2 monkeys were seen going to the river. So we have at least 2 more animals going to the river. So that makes it 3 animals confirmed as going to the river. The statement 3 is, every monkey has 1 parrot each. It is stated that every monkey has 1 parrot each. It doesn't say that the monkeys were taking parrots with them. It is possible that even though every monkey had one parrot each, they had left the parrot somewhere else, not taking while going to the river. So, irrespective of whether we consider parrots as animals or otherwise, there is nothing in the question that confirms that the parrots were going or being taken to the river. Hence, we are left at the same position as at the end of statement 2, that is 3 animals confirmed as going to the river. Now comes the most interesting part. Coming to the final part, the question asked is how many of the animals went to the river. Important point to note here is it is asked how many of animals went to the river, not how many of them were going to the river. After understanding the problem statement properly and understanding the ask correctly, none of the animals went to the river. It can be for any reasons which doesn't matter, even though 3 of them were going to the river. Hence, if the question was how many of the animals were going to the river, the answer would have been 3. But since the question asked is how many of the animals went to the river, the data is insufficient to conclude the answer, as none of the statements confirms that any of the said animals actually went to the river. In my opinion, answer to this question is inconclusive or data given in the question is insufficient. It can have other interpretation. Please do comment your thought in the comment section. What gets one more when you take one away from it? You need to find something that gets one more when you take one away from it. Let me repeat the riddle. What gets one more when you take one away from it? The riddle requires some creative out of the box thinking, and the answer is not obvious. There is no wordplay hidden in the riddle. Take the question literally. The hint is try to apply your math knowledge to find the one thing that gets one more when you remove one from it. In order to solve this problem, one should have the knowledge on representation of numbers in Roman numerals. Roman numerals are written using 7 different letters I, V, X, L, C, D and M. They represent the numbers 1, 5, 10, 50, 100, 500 and 1000. We use these 7 letters to make up thousands of others. For example, the Roman numeral for 2 is written as I. The Roman numeral for 3 is written as I. But 4 is not written in the same way. Instead, the subtraction principle is used. The number 4 is written as IV. Here we have I, which is 1, before V, which is 5, and because the smaller number is before the larger number, we know that we have to subtract here, making IV4. So to solve this riddle, you need to think of the Roman numerals. Now we know that Roman numerals have a unique numbering system where the number before a multiple of 5 is written distinctively. In Roman numerals, the numbers 1 to 5 are written like this. Look at the number 4 and 5 in Roman numerals. 4 is depicted with an I and a V, while 5 is just a V. Now look back at the riddle. What gets one more when you take away 1? The answer is number 4, which is represented in Roman numerals as IV. When you remove I from IV, that is from 4, you get V, which is 5. Therefore, you get one more by removing 1. Thus, answer to this riddle is 4 when the number is represented in Roman numerals. There are 49 dogs signed up to compete in the dog show. There are 36 more small dogs than large dogs signed up to compete. How many small dogs are signed up to compete? To break it down, if there are 49 dogs total and there are 36 more small dogs than large dogs, you would subtract 36 from 49. By that measure, there are 13 large dogs and 36 small dogs. So that means the answer is 36 small dogs, right? Is that a trick question? Apparently not. Feel free to pause the video and give a try before checking the solution. I will be back in 10 seconds with the answer. The real answer is 42.5. S. 42 and a off dog. Yet somehow, even with the correct answer, we are still scratching our heads. A off dog? Yes. Here is why. 49 minus 36 is 13. 13 divided by 2 is 6 and off. So 36 plus 6 and off is equal to 42.5. Another simple way to solve this problem is through algebra. Let x equal the number of large dogs. Hence, x plus 36 is the number of small dogs. So x, which is the total number of large dogs plus the number of small dogs, equals 49. That's the same as saying 2x plus 36, which is equal to 49. 2x is because, as per the question, there are 36 more small dogs than large dogs. The base for both large and small dogs is x. After substituting the values, x equals 13 over 2, which is equal to 6.5. So there are 6.5 large dogs and 42.5 small dogs. So there are multiple interpretations to this problem. I have picked one such interesting interpretation from Quora. Accordingly, many people have, of course, noted that a direct reading of this problem leads to the conclusion that there are 42 and a half small dogs and thus 6 and a half large dogs, which is seemingly invalid. However, there are ways to resolve this apparent inconsistency within the limitations of the problem. You may not be able to get an exact answer, but you will be able to establish constraints on the range of possible answers, which is better than simply saying there is no feasible way to satisfy the requirements of this problem. Both of these rely on rejecting the unstated assumption that small dogs and large dogs form a complete partition of the set of all dogs registered. One way is to think is that a possibility that at least one dog is registered in both the small and large categories. Thus, the sum of small dogs and large dogs is greater than 49 because the categories overlap. There are multiple possible solutions. Here are some possible ways. 42 small only dogs, 1 small and large dog, and 6 large only dogs satisfies the problem. There are 49 dogs, 43 of which are small and 7 of which are large, satisfying the constraints. Similarly, you can have 41 small only, 3 small and large, and 5 large only. And so on up to 37 small only, 11 small and large, and 1 large only. Another way to think about this is the possibility that there is a third category of dogs, which we will call dogs of an unusual size, which are neither large nor small. In this case, there are 7 possible solutions, the first of which is 36 small, 0 large, and 13 dogs of an unusual size, and the last of which is 42 small, 6 large, and 1 dog of an unusual size. Here, the point is, of course, is that the problem is solvable if you reject the unstated assumption that every dog is exactly one of large and small. So it has officially been confirmed a off dog did in fact compete in this dog show.